This is example number 2, section 4.5. You have to determine the form of the particular solution for y double prime plus 3y equals to 5x e to negative 2x cosine of x minus 3 e to negative 2x sine of x. So we need to find the particular solution, right? But we don't need to solve the equation actually. So remember, the particular solution is coming from f of x. What is f of x? F of x is the right side of the differential equation, which is in this case 5x e to negative 2x times cosine of x minus 3 e to negative 2x sine of x. So we have to find the form of the particular solution. Right? The particular solution looks like what? Well, recall that comparing the right side to the three cases we know, we see that looks like this, right? Looks like this. We have an exponential multiplying trigonometric functions. So how is going to look like in general the form of the particular solution? Well, let's see. We have that because we have on the right this term in blue, x, then that means that m is equal to 1. M is equal to 1 because we have x to the 1 on the right multiplying an exponential and trigonometric function. Because of, so let me have the same color. So using the same color is going to help. So the green portion, the exponential, gc to negative 2x implies that r is going to be equals to negative 2. R is going to be negative 2, and that is due because of the expression coming from the right. Now, or this r is also called alpha. Now, look that we have the terms, we have cosine of x also, and then we have sine of x. Okay, so the argument of these two trigonometric functions, the inside or the number which is multiplying x, that is always referred as argument, is going to be given beta. Beta is then 1. Okay, beta is 1. Now, we also need to determine if we have to multiply by a term x to the s, and this x to the s, we find it by solving the auxiliary equation from the homogeneous equation, which is in this case y double prime plus 3y equal to 0. So the auxiliary equation is going to be r squared plus 3 equals 0. And we solve the equation, we have r equals 2 plus and minus the square root of 3 and also I. Okay. Now, the question is, this solution of R, these are, is R equal to alpha? The answer is no. So the term x to the s is going to be x to the 0 because the solution of the auxiliary equation is not the same as the alpha and the beta coming from the right part. So how is going to look like yp? Yp. That's what we have to find. Okay, the problem is asking for determine the form of a particular solution for the given equation, and remember the particular solution is given by the right side of the equation. So we need to, now we don't need to use, or we don't need to solve the general solution that involves the complementary and the particular. In this problem, just the form, how looks like. So well, looks like what? It's gonna look like x is 0, right? Since we have an x multiplying cosine of x, then we're gonna have a polynomial inside. So you're gonna have a x to the 1, a to the 1 plus a sub 0 times e to the same exponential as the given on the right, cosine of x plus the same thing, but for now the sine. Okay, now for the sine. And remember, anything to 0 power is 1. Okay, so it's just like this. So it's a 1x plus a sub 0 times the exponential times cosine of x plus v1x plus b0 e to negative 2x sine of x. And this concludes the problem, because the only thing we have to do is determine the form. We don't have to solve anything. This is the end.